Okay, so this is video for lesson 432, still quadratic functions. So on Tuesday, we graphed using transformations. Today, we're going to graph using the vertex, the axis of symmetry, the intercepts, all different things. I'm still going to show you one problem that you can still do what we did Tuesday. So you can kind of mix these up a little bit on your method. Okay, so our first function we're going to look at is x squared plus 4x. Now, when you're looking at a quadratic function, if it's in standard form like this one is, whatever's in front of x squared is your a value. So nothing's there, so it's understood 1. Whatever is in your second term in front of x, that's your b. If there's no constant, which this one doesn't, that would be your c, so it's 0. So we're going to use this is the axis of symmetry form. You can call it your vertex. It's a way to find the x coordinate of your vertex, which also ends up being the number in your axis of symmetry. We'll talk about all that. But you're going to use this little formula, negative b over 2a. And as you can see, in the formula, there's an a and a b. So we know a is 1, b is 4. The other thing, before I move on, the first thing that these problems are going to ask you is, does the graph open up or down? Well, whatever a is determines how it opens. So if a is a positive, so since it's a positive 1, this graph opens up. So that's the first thing they're going to ask you. If a, whatever's in front of x, is a negative, then it would have opened down. We'll look at one of those in a minute. So this one's going to open up. You're going to answer that first. Then you're going to do your axis of symmetry and your vertex. So we're going to start here. So b is the 4. So we're just going to substitute those numbers in. A is the 1, so it's 2 times 1. So that'll be negative 4 over 2 times 1, which will be reduced to negative 2. So what we just found is your axis of symmetry. And I can't remember what order this asks it in, if it does the vertex first or the axis of symmetry first. But the axis of symmetry, when I ask for that, you're going to say is x equals negative 2. And we'll look at that in a minute when we graph it. But the axis of symmetry is the line that goes down the center of your parabola. Now let's talk about how we finish to find the vertex. Well, now that we know x is negative 2, we go back to our original function. And remember, this is f of x notation, but it also is the same thing as y. So I'm going to change that to y equals, and I'm going to put in a negative 2 for both my x's. So I'm substituting that negative 2 in. And what that's going to do is now get us our y coordinate of our vertex. So then negative 2 squared. And remember, if you have a negative and you have an exponent, put it in parentheses. Negative 2 squared is positive 4. Because if you don't put it in parentheses, you're going to think it's negative 4. And then that's going to be negative 4 because 4 minus 8. So now your vertex, that's another answer it's going to want. Your vertex is the ordered pair, negative 2, negative 4. And we're going to use that in a minute to graph as well. So then the next thing you're going to need is you're going to need your x and your y intercepts. So if you remember, we've done these before. So if I need my x-intercepts, remember, you're going to zero out your y. If I need my y-intercepts, I'm going to zero out my x's. Okay, so let's do our y first. So that means it's going to go 0 equals x squared plus 4x. Okay, so now what I can do is we're going to revisit some old things we've learned before. We have a GCF in this. So that means I can pull an x out as my GCF. Remember when we did that? So if I pull an x out of each one of these terms, you have an x left, and you have a 4 left in that one. And then remember, we've done these before. Once we have it factored, then we can set each factor equal to 0. and then you can solve those out, and that gives you your x-intercepts. So that one's just 0. This one solves out to -4. So then you're going to put in, it's going to ask for your x-intercepts. You're going to do -4, 0. No parentheses. So that's your x-intercepts. Now your y-intercept. So your y-intercept, you put a 0, the x's are. This one's a little bit easier. So it'll be y equals, so I'll put a 0 and then squared. So remember, going back to your original function, plus 4 times 0. And then now, those just all 0 out. So your y-intercept is just 0. You'll put that in, okay? The next thing it's going to have you do after you do that is it's going to ask to graph. It's going to have you graph it. So you're going to have to get on your graph. It'll have a graph there. You click on the graph. Then you're going to click that you want a parabola. There's a picture of a parabola in the bottom. So the first thing you'll do is graph. So then it'll give you like a cursor or a dot. So you'll drag your dot to the vertex. Remember what our vertex was? We found was -2, -4. So you'll first graph that, -2, -4. So you'll go there. At first, it's going to make a straight line because it needs more points to show that it's a parabola. So the next thing you can do, you can graph, after you graph your vertex, you can do any of these other points. You could do your y-intercept, so that ordered pair for your y-intercept. Oops, I got the wrong paper. The point for this, your y-intercept would just be 0, 0. So you could plot that point. You could go over here, you could plot your x-intercepts. You have an x-intercept of -4, 0. Or 0, 0. You could do any of those 3 points. It doesn't matter which one. It just needs you to graph a second point. So I'm just going to, once you have that, you're going to drag your cursor or your dot, and I'm just going to do the 0, 0 one. Click that. Once you click a second point on that graph, then it'll draw your parabola. And just to make sure, since I'm doing mine by hand, I'm going to do that other x-intercept would go across at -4, just so mine's, whoops, a little bit longer. Okay, so then it'll draw your parabola. So now let's talk about the axis of symmetry. Remember that axis of symmetry was x equals -2? What that means is if there was a line that came down and cut this parabola in half, it would go through at x equals -2 right there. That's your axis of symmetry. Okay, so now that you have it graphed, the next thing it's going to ask for, and these are things that we've done before, it's going to ask for domain. And again, remember on these problems, they have you check after each one because they don't want you to go all the way to the end and then have to find out everything that you've missed. So you're going to they make you take it step by step, checking each one as you go. Okay, so our range, our domain. So remember, our domain is our side to side. Well, this one starts -infinity. It's going to just keep going. This parabola is going to keep going out wider and wider to -infinity. It's going to keep going out wider and wider to positive. So your domain is -infinity to +infinity. And it's parentheses, remember, because it never stops, okay? Your range does have a starting point right here. That was at -4. So that's going to start at -4 with a bracket. And then it's going to go to +infinity with a parentheses. Now you're going to do those increasing and decreasing intervals. We've done those before. So that would be, if I were doing my increasing, I would start at this point. And remember, you're using the x-axis to do those. So your x coordinate from this point is -2. That's your axis of symmetry. It's increasing. That means it's going up. That's your increasing. So that interval is from -2. Remember, on the x-axis, -2 to infinity. And remember, you do not use brackets, or you always, on the increasing and decreasing, you always use parentheses. Then on my decreasing, that's on this side, going down. So you're decreasing, it's decreasing over here. That's on my x-axis, is going from -infinity to the -2 on the x-axis. So that would be negative infinity to negative 2. And that's your decreasing. And that's everything that it's going to ask you on that problem. Okay, so let's look at another one. So this is another one, but I mentioned a minute ago, you can actually do some vertex form or the transformations on some of these. If you just kind of pay attention to the function, it's easy to kind of put it in that vertex form that we've talked about now. So here's our function. First of all, answer, does it open up or down? Well, again, you have a positive, there's no negative here in front of your x squared, so this is going to open up. Graph opens up. First thing you're going to answer. So the next thing it needs is the vertex. Well, remember, we can find the vertex using that method we did 2 days ago where we put it in vertex form. So remember how we do that. We're going to take this trinomial. I'm going to take my function notation off of it right now. And I'm going to complete the square. So remember how we did that. We make a blank for our new constant. We're going to move our 8 over, because it needs to be on the other side, because we don't need it anymore. We don't need it here. We need to find a new constant. But it doesn't go away, so it just moves to the other side. So remember how we did that. We took this middle term, we divided it by 2, and then we squared it. So our new constant is 1. What we add here, we add here. And then now we can make that binomial squared. So it's going to be x, remember, use this sign, plus square root of 1 is just 1, and then square your binomial. And then the 9, we need to put our function notation back on. The 9, which that's what that's going to equal, needs to come back as a negative. And so now remember, this was called vertex form. And remember, we also used it to do our transformations. So whatever number's in here in the function, that's your x coordinate of your vertex. So our vertex is going to be net. Remember, if it's plus 1, it was actually negative 1. And then this is your y coordinate of your vertex. And remember, that was also how it shifted. It's going to shift left 1, shift down 9. It's the same. You can use the same form for both things. But this is your vertex. So therefore, your axis of symmetry, so you don't even have to use that little formula now because we have our vertex. Because whatever the x coordinate of the vertex is, that is your axis of symmetry. You just have to say x. You have to make it an equation. X equals negative 1. So that would be the line that would go down the center of the parabola. Okay, so the next thing we need to find is we need to find our x and y intercepts. It's going to ask for those. So we're going to zero out the y's for our y-intercept. We're going to zero out our x's. So then on this one, so we're going to still take this form, okay? And what we're going to do is we're going to separate these again. We're going to take the 9 and we're going to put it on the other side of the equal sign, taking that function notation off. We don't need it. We can pretend that we set it equal to 0 because we're trying to solve this. So we're going to move the 9 over. So it's going to be 9. It's positive now because that was a minus 9 there. And then we're going to have our binomial squared. And then remember that little rule. If I have perfect squares, then I can take the square root of both sides. We've talked about this before. So if I take the square root of 9, remember that's a positive negative 3. And then on this one, remember it just lifts everything. So x plus 1 is left because you're just going to lift the square. Square root undoes a square. So now we can solve this out. We're going to subtract 1 over here, and I'm going to rewrite all this so it looks more in order. So I'm going to subtract the 1 over here, so it's going to look like this. Negative 1 plus or minus 3. So now I can do negative 1 plus 3, which is 2, and I can do negative 1 minus 3, which is negative 4. And those are your two x-intercepts. And remember, when we graph in a minute, you can use these as your ordered pairs to graph. When you're going to use that graphing tool, those can be your second points if you want them to be. So now let's do our x-intercept, or our y-intercept. Sorry, we're going to zero out our x. So I'm going to put y where my function notation is. I'm going back to this. Put y where your function notation is. and then put a 0 where your x is. So inside here is 0 plus 1 is 1. Well, 1 squared is just 1. And then that's going to equal negative 8. So this ordered pair, if we need to graph that in a minute, is 0, negative 8. But negative 8 is your y-intercept. Okay, so now we need to go graph. So you go to your graph. It'll have a graph on there. Now you click your graph. And again, you got to click that you're doing a parabola. So click the parabola. First, graph your vertex. So your vertex back up here was negative 1, negative 9. So we're going to go negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex. Then I need a second point. For my sake, since I'm hand drawing these, I'm going to do my x-intercepts. You can just click on the y-intercept if you want, and it'll make your parabola. But I'm going to click on my 2, 0 and my negative 4, 0. So 2, 0 would be here. So if I was on the computer at this point, it would draw my parabola. But I'm going to go ahead and do my negative 4, and then there's my parabola. Okay, so now it's going to ask for domain, range, increasing interval, decreasing interval. Okay, so your domain, remember side to side, since this is going to keep going out further and further as the parabola gets bigger, your domain is going to be negative infinity. It's never going to stop either way to positive infinity. Range does have a starting point at negative 9, and then it's going to go to infinity. And remember, it's a bracket. I almost drew that wrong. It's a bracket at negative 9 because it has a starting point. And then it goes just to positive infinity forever. Okay, you're increasing. Remember, using your x-axis, it goes from here, which was negative 1, and it's going to go, increasing is this way, so it's going to go negative 1 to infinity. And remember, use those parentheses on the increasing and decreasing. And then it's going to go for your decreasing. Wait a minute. What was my vertex again? Okay, I was thinking I did my vertex wrong, but I didn't. I think I'm looking at the wrong problem. Okay, just afraid I was looking at the wrong problem, but I'm not. Okay, so it's going to, so decreasing is going from negative infinity to that negative 1. So on the, remember, on the x-axis, so it's going to be out here negative infinity, it's going to go to negative 1, and that's where that point is even with. So negative infinity to negative 1, and that's your decreasing, and that's everything it's going to ask for. Okay, so we're going to do one more. These are going to be a little bit shorter, I think. You're not going to have to do the x-intercept. That's the only thing that it doesn't have you do. But I wanted to talk about one function with a negative where it would go down, because we haven't looked at one where it would go down. Okay, so this function, if you notice, remember, still the first thing it's going to ask you is it go up or down. Well, look what we have here. We have a negative coefficient to like a leading coefficient. That means the graph opens down. That's the first thing you're going to answer. Now, this one, we're going to go back to that little formula we used on the first one. We're going to have to go back and use that. So we're going to use that. And remember, A is whatever's in front of x squared. So A is negative 2. B is 2. This one does have a C. We don't need it for the formula. We just need A and B. So we're going to put negative 2 on the top. And on the bottom is 2 times A. So that'll be 2 times negative 2. which this will be -2 over -4, which will be 1/2. Now this one is going to be a little bit more difficult because you are going to get fractions, but it's not going to be too bad. All right, the next thing we need to do, so this is your axis of symmetry. So it'll ask for that again at some point. Axis of symmetry is x equals 1/2. Now we need to put this x in, this 1/2 into our function up here to get our y coordinate of our vertex. So now everywhere there's an x, we're going to put a 1/2 in there. Remember, put a parentheses around it. Okay, so on this one, first thing we need to do is square 1/2. So 1/2 times 1/2 is 1/4. So that'll be -2 times 1/4 plus, now 2 times 1/2 actually is going to equal 1. If you multiply that, that equals 1. So that gets rid of our fraction there, and then that's going to be -2. So here, -2 times 1/4 would be -2 over 4, and then you can reduce that, so it would be -1/2. Here, this equals -1 if you put those together. And then, now if you finish this, those are both negatives, so you add them, so you can just put it together as 1 and 1/2. So your vertex is, the x was the 1/2 when we got our axis of symmetry, and our y coordinate is the -1 and 1/2. Okay? What's going to be easy about this when you graph, you'll notice your graph, when you're trying to find your vertex, that graph is going to go by halves. So it's going to be real easy. Even though there's fractions, it's not hard to graph it. Okay, so we've got our axis of symmetry. Now we need to find, okay, so on this one, you're not going to have to find the x and the y-intercept like you do on the other ones. All they're going to want is the y-intercept. So, which is going to make your life so much easier on this one. So if I want the y-intercept, I just zero out my x's. Because if you had to find the x-intercept on this problem, it would take, you would probably have to completely use the quadratic formula, but you don't have to. So you're just going to find your y-intercept, zero out your x's, so go back to your original function. So here's my original function. So I'm going to put zeros where all my x's are and leave y for your notation. So -2 times 0 squared plus 2 times 0 minus 2. So then I'll work all that out. That term's going to equal 0. That term's going to equal 0. My y-intercept is -2. See how easy that was? So this ordered pair, when I need to graph this in a minute, because you're going to use this as your other point, is 0, -2. Okay, so that's what we're going to do next. We are going to graph. So you're going to go to your graph. And remember, like I told you, it seems like it's going to be difficult because of the fraction for the vertex, but it really isn't, because like once you click on your graph, click your parabola, once you start moving your vertex around, you're going to notice, if you haven't noticed before, but when you're graphing, it shows your ordered pair like right down here, I think, in that area. And when you move it around, if you'll look at that, it shows down there what the ordered pair, where you're at, okay? So I'm going to move it to, I would go 1/2. So I'm going to do halves marks. These are half marks. So I'm going to go over 1/2, and then I'm going to go down 1 and 1/2. So I'm going to go a half, a whole, and then 1 and 1/2 would be that mark. And that's how their graph is on the computer. Then I need to do my y-intercept of 0, -2. So then 0, and then I'm going to go -2. Now remember, this graph opens down. Remember, we already decided that. So that's what you're going to find when you do this. Because you go 0, and if I go down 2, remember, I'm going by halves. Half, whole, 1 1/2, 2. Right there would be my second point. And look, that parabola is going to go down, which it's supposed to. So it'll draw your parabola for you. And then you're going to go through and you're going to do your domain, just like we've been doing, your range, your increasing interval, and your decreasing interval. Okay, your domain. Domain is the same as it has been. It's still going to be -infinity to +infinity. That doesn't change. just because it's going upside down. Range does, because now your bottom of your graph is going to negative infinity. Then it goes up to the negative 1.5. So it's going to be negative infinity to negative 1.5, and then that's your bracket, because that's your stopping point. Your increasing is this side this time. So this side's going up. That's your increasing. That's where it's increasing. So that's going to be negative infinity to, remember, you're using the x coordinate, or the x variable. So it's going to go negative infinity, and that, remember, that was the half mark. So at a half. So negative infinity to 1/2 is your increasing. And then your decreasing is from here to here. And so 1/2 to positive. Remember, you're using your x. It's going out positive. This going negative infinity. So this one's going to be 1/2 to positive infinity. Remember, on your increasing and decreasing, it's like you're doing the domain. Okay, think of it like that. Except you're just doing half of the parabola at a time. Think of it like that. Okay? All right, so that's it on that one. So you'll have several of these. And then remember, like when I did this one, when you get to these problems, and you'll be able to tell when you transition to a different problem because the instructions are a little bit different. You don't have to find the x-intercepts like we were on the first ones, because it was asking for the x-intercepts. These problems are not going to ask for the x-intercepts. There's no reason to find the x-intercept if it's not going to ask for it, because that's just going to put a lot more work on you. So all you need to find is the y-intercept, because that's going to be enough along with the vertex, because you'll have to find the vertex, and then you'll have your y-intercept, and then you'll be able to graph it. Because you just, on these graphs, you just need 2 points on that graph to be able to graph it. All right, that's it.